shows differentiation of parametric functions. Basically, two or more than two expressions will be given to you, right? And from that, sorry, in the last class, I think we have covered, yeah, second order derivative, right? So we had to differentiate a function twice and then put those values inside the equation that we need to prove. Now, after this, we will be starting with miscellaneous exercise from this chapter, which will include the questions from each of the concept randomly. So that will also give us a better idea about how we have prepared. Guys, were you able to solve these two questions, or do I need to solve them? I would like to ask whether you solved these questions or not. If not, if somebody needs help, then we will first solve these two questions and then we will proceed to. Also, please feel free to ask your doubts regarding the last exercise or any exercise. Any question from differentiation continuity which you are facing a problem with, please feel free to discuss that. And also tell me if you need help with these two questions. You have 2 minutes, please. If you have any doubt, you can ask me that. Okay, in that case, we will be starting with our practice questions. If you don't have anything to ask. Let's try this one. You need to differentiate the following function with respect to x. So you basically need to find out dy by dx. In every case, you need to find out dy by dx. Now, I would like what I would like, how I would like you to approach this question is, you need to first understand which type of differentiation it is. So before that, we need to revise what are the different types of differentiation. So first of all, we understood differentiation of implicit function, right? In which y and x cannot be separated out, right? So differentiation of implicit function. Then differentiation of ITF, right? After differentiation of ITF, we had exponential differentiation. Then logarithmic. Then parametric. And last, second order derivative. So first of all, you need to understand which category is our given differentiation falling into, so that you can subsequently apply the right rule or the methods you have understood. So which kind of differentiation it is? Tan inverse sin x upon 1 plus cos x. ITF, right? So let's start with correct. Let's start with proper substitution now. In ITF, we used to first reduce the function. So in this, first reduce the function. You can understand that the given function is tan inverse sin x upon 1 plus cos x. So somehow it can be reduced. You just need the right substitution. So how should we put the right substitution? Either substitution, or you need to reduce this function, trigonometric function. So, I mean, reduction of function can be done either through some trigonometric identity, या तो आप यहाँ पे कोई भी trigonometric identity use करके इसको tan inverse के अंदर tan बना दो, या फिर कोई substitution करके, right? Substitution used to happen when there is an algebraic function was given, and when there is a trigonometric function is given, then how can we reduce the function? We need to use different trigonometric identities, right? So try to use double angle formula. Double angle formula is very popular for sin x, I mean sin 2x, cos 2x, both of them. In this case, you need to apply them, I mean double angle formula only, but if somebody can help me out with this, I mean, what formula can we use? So can anybody tell me the formula of sin 2x? How do you open sine 2x?
2 sin x cos x.
2 sin x cos x, right? So in the same way, if I want to open sine x, how can I open sine x? Using the double angle formula. Okay, if it was sine 2x.
Sin x by 2 into cos x by.
Yes, correct. We just need to divide the angle by 2. Correct side. So it should be written as 2 sin x by 2 cos x by 2. Correct. Now, can you tell me how do you write cos 2x? In the form of cos or in the form of sine? Cos 2x is 2 cos square x minus 1, no? 2 cos square x minus 1. If I take 1 to the left hand side, then it becomes 1 plus cos 2x. 1 plus cos 2x is 2 cos square x. Another formula. Very important set of rules. This also and this also. All of the three properties will be used extensively over reduction techniques and when we go to integration also. So remember these 5 formulae very clearly. You have to use them many more times. So you can see that here 1 plus cos x is written. Using this analogy, we can write 1 plus cos x as 2 cos square x by 2. If the angle is 2x, then the angle is x here. If the angle is x here, 1 plus cos x, then 1 plus cos x can be written as 2 cos square x by 2. Now see, 2 got cancelled out. 1 cos x by 2 will cancel 1 cos x by 2 in the denominator. So you are left with sin x by 2 divided by cos x by 2, right? Which can further be written as tan x by 2. Sin x by 2 divided by cos x by 2 is tan x by 2. It implies that your y is nothing but x by 2. Now what is dy by dx? 1 by 2. So now we will try to apply all of these set of rules. All of the rules, Mani, the question can be from randomly, the questions will be randomly distributed from any of the rule and we need to solve them. First understand which kind of differentiation it is using, then try to use the methodology that we have discussed in that particular form. This is a very good question, by the way. Both of the question, okay, first of all, which category of differentiation it is?
ITF.
ITF again, right? Now in the first case, that function inside the inverse trigonometric function, that is tan inverse, the function inside that was a trigonometric function, sin x upon 1 plus cos x. So we used trigonometric functions or we used trigonometric identities to reduce the function. What is our basic goal? Basic goal is to reduce the function, right? How can we reduce the function? We have to reduce the function. We had to actually remove this inverse trigonometric function, which is applied on the outside of the whole function, right? तो पहले केस में tan inverse था, we have removed tan inverse. Now in the second case, we need to remove sin inverse, right? That is how we can reduce the function. But inside, the function given is 2 to the power x plus 1 divided by 1 plus 4x, 1 plus 4 to the power x, right? Now, any kind of function other than trigonometric function can only be reduced by substitution. If there is a trigonometric function inside, then you have to use trigonometric identities. But if there is not a trigonometric function, in that case, every time you will have to use a substitution. Now, you need to identify two things for substitution. We have discussed this. Just a minute. Yeah. So in all other functions, which may include your algebraic function, exponential function, or any kind of function other than trigonometric function, you will have to use substitution. And for substitution, you need to remember two things. First, the term which needs to be substituted. ऐसी term कौन सी है जो मेरे को substitute करनी पड़ेगी? What is that term? And second, what is the substitution? आप उस term को किसके equal put करोगे? What will be your substitution? Right? So first thing and second thing both basically relates to this. पहली बात भी और जो सेकंड बात भी, हम जो दोनों रूल बोल रहे हैं, एक ही है कि हमें टर्म ढूंढनी पड़ेगी किस टर्म को सब्स्टिट्यूट करना है, एंड सेकंड इज कि उस टर्म को क्या सब्स्टिट्यूट करना है, राइट? बट ये दोनों ही बातें इस चीज पर डिपेंड करेंगी कि आप अंदर क्या फॉर्मूला बनाने वाले हैं. आप एक बार चाहे तो वापस आके यहाँ पे देख भी सकते हैं ITF के केस में, जब हम या तो हमने बहुत सारे सब कुछ लिखा था. Yeah, compare the given algebraic equation, given equation rather than algebraic, I would say given equation with some trigonometric formula, for proper substitution, right? So we need to understand these two things. Okay, how can we, matlab, what to put and what to substitute and what will be substituted, and in place of substitution, what will come, right? And for that, compare the given equation with some trigonometric formula, right? So in this case, if you take this, then first of all, we need to understand what to substitute, and then after that, what trigonometric formula we can fit in this, right? So usse pehle, before that, just write this properly. Write this properly, Vane, change it to something so that it can become a formula. So I'm writing 2 to the power x plus 1 as 2 into 2 to the power x, right? This is 2 to the power 1, this is 2 to the power x. If I multiply them, this will become 2 to the power x plus 1. So I'm writing this as 2 into 2 to the power x divided by 1 plus, now this 4 to the power x can be written as 2 to the power 2 whole power x, right? 4 is what? 2 square. So 4 to the power x is what? 2 to the power 2 whole x. And this can be written as 2 to the power 2x, right? And 2 to the power x can be written as 2 to the power x whole square. I mean, we can interchange 2 and x. What I'm saying is, right? Both are same things. So instead of this, I'm writing it here directly. I will write the explanation in the brackets that we are writing 4 to the power x as 2 to the power 2 whole power x, which is basically 2 to the power 2x, which is basically this, right? Now, why would I write this like this? So if I substitute 2 to the power x now, if I substitute 2 to the power x now in this case, I can make it equivalent to a trigonometric equation. Now, which trigonometric equation? For that, you need your center page. Please find this out and tell me. Fatafat. Anji, do you have your center page with you? Okay. Put 2 to the power x as tan theta. So this will become 2 tan theta divided by 1 plus tan theta whole square. Is it a formula for something? So it is actually, but you need to tell me what is the formula. If I put 2 to the power x as tan theta, it means that theta is tan inverse 2 to the power x. Sine 2 theta, correct, Shai. So if I put 2 to the power x as tan theta, then what does it become? Sine inverse. This is 2 tan theta divided by 1 plus tan square theta, which is a formula for sine 2 theta. Which is a formula for sine 2 theta. So actually, it becomes y is equals to 2 theta. Now, guys, we have not discussed other aspect of this, but we don't need it for the boards. But if you want to understand, then you can also, you should know this. In every case, we need to understand the domain and range of these functions also. Matlab, we are directly differentiating it, that is cool because it does not concern our syllabus. But if asked for a proper solution, then we should also make it clear that what are the values of x and y that is valid for this particular expression, right? Because for those values only you can find differentiation. तो हमें ये बताना चाहिए कि 2 to the power x plus 1 divided by 1 plus 4 to the power x should lie between -1 to 1. Why? Because this is the domain of sine inverse. If 2 to the power x plus 1 upon 1 plus 4 to the power x is not lying between -1 to 1, then this function cannot exist. So we need to specify this, and we also need to check कि क्या ऐसा है भी, if this is true or not. If it's not true, means that inside sine inverse you are given a function whose values are not lying between -1 and 1, then that function will not be valid. Subsequently, you don't need to find the differentiation because that function is not valid, right? But we are doing it because we know that the function is valid. Even, in fact, the function is valid for all real numbers. This may be the case that after solving this equation, you get x like this. I mean, for some particular question, you may get answers like this. Okay, x belongs to 0 to 7. It means that the differentiation of function, whatever you are calculating, is only valid when x is between 0 to 7. Other than that, the differentiation is not valid because the function in itself is not valid, right? So we also need to do that part, but in our CBSE syllabus, we don't need to show this. CBSE नहीं पूछता यार हमसे इतनी सारी चीजें. So this is y is equals to 2 theta. Now you know what is theta.
Sir.
Theta. Yes, Shabbos.
J it will come.
Yes, JEE बिल्कुल पूछता है. JEE इस पे questions change करेगा.
Yes.
So y is equals to 2 theta. Theta is basically tan inverse 2 to the power x. So this is y is equals to twice tan inverse 2 to the power x. Now I can find out the differentiation of this function dy by dx. It will come out pretty simple if we compare to the original function. Yeah, so differentiating with respect to x both sides. We get dy by dx in the left hand side, and we get 2 tan inverse. Now 2 is same. Tan inverse was 1 upon 1 plus x square. So this would be 1 upon, basically 2 upon 1 plus x square. X square bole to 2 to the power x whole square, right? We will have to apply chain rule. Then we will go to 2 to the power x. So 2 to the power x will be 2 to the power x log 2. Right? So this will be a final answer. It actually can be written as 2 to the power x plus 1 divided by 1 plus 4 to the power x log 2. Guys, please feel free to discuss your doubts. अगर कहीं पे भी problem है, समझ नहीं आ रहा, questions, I mean, the difficulty level of today's questions will be greater than we have been solving in the last classes. So feel free to discuss anything.
How did you get 2 raised to x plus 1?
This is 2 to the power 1 and this is 2 to the power x. They both are in multiplication. So this becomes 2 to the power x plus 1 when we multiply them. No, Harif, if we multiply 2 to the power 2 and 2 to the power 3, then it will
Yes,
be 2 to the
I
power
didn't see it. I mean, most of the questions will apply, your basic calculative skills, basic techniques, basic mathematical techniques that can be used to reduce a given function. So you have to understand things like these. And everybody is done?
Yes, sir.
Let's solve this one.
This is a positive constant a. So a is basically a constant number, can take any positive value, 1.5, 2, 3, 4, 5, 6, 7.9, whatever. We don't know that value, but this is a positive constant. And y is given in terms of a and t. So basically t is your variable, right? So you need to find out dy by dx. Y and x both are given to you, but in the form of a and t. A is a constant, t is a variable. So can you first tell me which kind of differentiation this is?
Parametric.
Parametric, right? And inside the parametric, if I go, then y function is exponential function. No, constant to the power variable. And x function is like algebraic function, variable to the power constant. So inside, it is also containing your basic differentiation, which is exponential differentiation and algebraic differentiation. So find out dy by dx, please. What of it? Anji, what would be dy by dx? Sorry, dy by dt. First of all, what would be dy by dx? How can we calculate? Can we calculate dy by dx directly here? No, because y and x do not have a direct relationship, right? So how can we calculate dy by dx?
So dy by dt and dx by dt.
Correct. So we need to find out two things, dy by dt and dx by dt, and then we need to divide them. So that dt gets cancelled out, we get dy by dx, right? So let's find out dy by dt and dx by dt now. So dy by dt, first start with this. Dy by dt would be, this is an exponential function. So dy by dt would be a to the power x, same. Then log a, right? This was exponential. But this is not exactly exponential. We have to also apply chain rule because this is t plus 1 upon t. So let's now differentiate t plus 1 upon t. T is 1, 1 upon t is minus 1 upon t square. Right? Now let's come to dx by dt. Dx by dt is what? Algebraic function, constant power, power outside, reduce the power by 1. Then go to t plus 1 upon t. T plus 1 upon t would be what? 1 minus 1 upon t square. Is it good for everyone? I mean, everybody understood this or not? If there is a problem, please.
Yes,
Okay, let's find out dy by dx. So it should be dy by dt, which is a to the power t plus 1 upon t log a and 1 minus 1 upon t square. Right? Divided by dx by dt, which is a t plus 1 upon t to the whole power a minus 1 and then 1 minus 1 upon t square. This will get cancelled out. So the final answer is log a by a to the power t plus 1 upon t divided by t plus 1 upon t to the power a minus 1. Okay, let's understand one more kind of parametric form, which will not be given directly, which may, I mean, you may not be able to understand it in the first sight, but understand how can we identify this is also an parametric form. So it is given that differentiate sine square x with respect to e to the power cos x. Now, whatever you have understood, whatever you have done in differentiation, every time you have done differentiation, it was in terms of one variable, right? It was never in terms of a function. I mean, we know what is the differentiation of sine x with respect to x. We don't know the differentiation of sine x with respect to cos x. No, we know the differentiation of sine x with respect to x. We don't even know the differentiation of sine y with respect to x, but that we can calculate with the help of chain rule. What I'm saying is, हम इसको जानते हैं भाई, sin x को आपको x के रिस्पेक्ट में डिफरेंशिएट कराना है, हाँ करा लो, आंसर क्या है, cos x है. sin y को x के रिस्पेक्ट में कराना है, नहीं हम नहीं जानते, बट हम रूल समझते हैं. We know the rule how we can differentiate this. How? We have to apply chain rule. So how can we do that? We can first differentiate sine, which will be cos, inside will be as it is. Then we can differentiate y with respect to x, which is dy by dx. Right? That is how we can differentiate sine y with respect to x. But if somebody asks me, okay, chalo, let's do this. No, I don't know this. Why? You have not been given any situation like this. I mean, at least directly. You have done this, but not directly. You don't know differentiation of
Separated.
sine. Sorry, yes, Travis.
So we have to divide, right?
No. We don't need to divide. It means that we have to find out the differentiation of sine x with respect to cos x. Now, this is similar to assuming that y is equals to, let's say, your one variable is y, which is equal to sine x, and your other variable is z, which is equal to cos x. So what you basically want to find out is dy by dz. What is dy by dz? Differentiation of sine x with respect to differentiation of cos x. Now, how can you do that? You first find out dy by dx from this, then you find out dz by dx from this, and then you divide both of the differentiation. Not the terms directly, but the differentiation of these terms. So whenever they give you a question like differentiate this function with respect to another function, then basically you need to assume these functions to equal to two variables. For example, you can consider sine square x as y and e to the power cos x as z. So this basically what they are asking you is find out dy by dz. Y is in terms of x, z is also in terms of x. Find out dy by dx, find out dz by dx, and then divide them to find out dy by dz. Right? Did you understand this process? If they ask you a question indirectly from parametric, then you will be able to solve, right? I mean, you know the whole concept. Just understand the question कि वो question वही पूछ रहे हैं जो तुम करके आए हो. बस ऐसे directly नहीं पूछ रहा. उसने तुम्हें इनके नाम नहीं दिए. उसने तुम्हें ऐसे function लिख के दे दिया. तुम अगर इसका नाम खुद से रखोगे, sin square x को y बोलो, e to the power cos x को z बोलो, तो तुम्हें समझ आ जाएगा dy by dz ही निकालना है, जिसको तुम ऑलरेडी जानते हो. जो तुमने ऊपर किया काम वो भी वही था. बस वहां पे y in terms of t and x in terms of t was given, and then you found out dy by dx, right? So the same thing can be done here. Same thing can be done here, and can be find out. I mean, the question can be solved. So let's solve one question with me, so that parametric form indirectly. Consider y is equals to sine square x and z is equals to e to the power cos x. Then we need to differentiate this function, which is y, with respect to e to the power cos x, which is z. So basically, we need to find out dy by dz. Right? Now, this dy by dz can be found out if you find out dy by dx, because y in terms of x is given, and z is also in terms of x given. So if you divide dy by dx with dz by dx, then you are cancelling out dx dx. So basically finding out dy by dz. So now, first find out dy by dx. First, y is equals to sine square x. Differentiate with respect to x both sides. So this would be dy by dx would be equal to what? 2 sine x first, power, then sine would be cos x. So what is this? 2 sine x cos x? Sine 2x. Right? Sine 2x. Then again, x is equals to, sorry, z is equals to what? E to the power cos x. Yeah, sorry. I got a phone call. Yeah, I think you understood this, right? dz, how did we get dz by dx? It was
Yes,
e to the
sir.
power cos x. It should be e to the power cos x into differentiation of cos x, which is minus sin x, right? Now I have already written sin 2x here, but now I am again writing 2 sin x cos x because sin x can be cancelled out. So it becomes minus of twice cos x divided by e to the power cos x. This would be the differentiation of sine square x with respect to. So finally, we should write the answer like this. Hence, differentiation of sine square x with respect to differentiation of e to the power cos x, differentiation of sine square x with respect to e to the power cos x is equal to minus 2 cos x divided by e to the power cos x. Okay, let's solve this one. We can move forward, right? I mean, if you haven't written, just tell me. I will scroll it up. चलो ये तो फटाफट ही कर देना यार, इस डोंट टेक मच टाइम इन दिस. Which kind of differentiation? Sin x minus cos x to the whole power sin x minus cos x. Which kind of differentiation first? First question.
Logarithmic.
Logarithmic differentiation, right? Variable to the power variable. So first we need to take log both sides. And then we need to proceed with differentiation. Chalo, fatafat. Then we will solve a good question. Actually, two good questions, not just one. Three. Let's take three. Nanji took log both sides. What will be the expression? Simplified expression. I'm writing the answer directly. कोई भी बता दो.
Sir, sin x minus cos x into log of sin x minus cos x.
Good. Differentiation. Left hand side after differentiation. No. We are differentiating log y, so it should be 1 upon y into dy by dx. पहले log का फिर y का. Right hand side, product rule. First sin x minus cos x. Log of sin x minus cos x will be as it is. So sin x minus cos x would be what? Cos x plus sin x. And log of sin x minus cos x as it is. Then plus sin x minus cos x as it is. Differentiate log of sin x minus cos x. So this should be what? 1 upon input. And then differentiation of sin x minus cos x, which would be cos x plus sin x. Same, ये वाला. They gets cancelled out, right? This cos x plus sin x is in both terms, first and second. So this can be written as y, then cos x plus sin x, then 1 plus log of sin x minus cos x. What have we done here? Cos of x plus sin x, दोनों terms में. This also and here also. They have cancelled each other. So we have taken cos x plus sin x common from first and second term. Second term में 1 बचा सिर्फ. Second term there is only 1 left, and in the first term log of sin x minus cos x was left. So dy by dx should be y times cos x plus sin x into 1 plus log of sin x minus cos x. That should be our final answer. First of all, this is an important question. It has already been asked in your CBSE board exams. Very good question. So an equation is given, x into root over 1 plus y plus y into root over 1 plus x. Right? And what you need to do is, you need to find out dy by dx, or basically y1, and prove that the value of y1 is minus 1 upon 1 plus x square. So how can we approach this question? First of all, what kind of question is this? Which kind of differentiation? I will solve the question only. You just need to answer me whatever I ask you guys in between questions, some in between questions. So can you identify the type of differentiation here? If yes, then please tell me. ITF नहीं है, no ITF, no logarithm, no exponential. चलो, first of all, let's be very clear. कौन सा नहीं है? Let's find that out. Which one of the above kind of differentiation is not possible here? So no exponential, no ITF, parametric, no, only one equation. Double second order derivative, no. Right? So क्या बचता है? Either logarithmic or implicit, right? बस 2 बचता है. Logarithmic दिख नहीं रहा, implicit दिख रहा है. This is an implicit function. You can't find out y in terms of x like directly. That is why the question is difficult. That is why the question is important. See, the question is given in terms of an implicit function. That is, you cannot separate out y and x very easily. Maybe you can't separate them out. In this case, you can't separate them out. But I mean, even then, you have to prove that dy by dx is completely in terms of x. That is why the question is important. You cannot identify the relationship between y and x, but even then, you need to prove that dy by dx is completely in terms of x. So basically, you have to what? Remove y from the answer. Now, how can we do that? We can first of all make this equation easier for us by how? By taking one term to the right hand side and then squaring both of the terms. एक तो वो काम कर सकते हैं, स्क्वायरिंग कर सकते हैं, इक्वेशन को थोड़ा रिड्यूस कर सकते हैं, और we can directly go for differentiation from this part only. Okay. X into root over 1 plus y is equals to minus times y into root over 1 plus x. Let's square both the sides. Right? Now let's differentiate. So this should be 2x into 1 plus y as it is, plus x square as it is. 1 plus y would be 1 is 0, y would be dy by dx. Now to the right hand side. Again, product rule, y square would be 2y first power, then y, and 1 plus x is as it is, plus y square as it is, and this would be 1 plus x would be 1, 0, and x would be 1. Right? Now let's combine dy by dx from here. So this would be, let's take this term to this side and this term to this side. So this becomes dy by dx I'm taking common. Here I'm left with x square minus 2y into 1 plus x. Is equals to y square minus 2x into 1 plus y. Right? So, yeah, we need to apply some substitutions, which can be applied like this. Anji, everybody done till this point? We have just applied product rules on both either sides, left hand side also and right hand side also. And we got this answer. So dy by dx is basically y square minus 2x into 1 plus y, right? Divided by x square minus 2y into 1 plus x. And we also have this equation. We also have this equation, remember that. Now, why I remember this? Because we are going to substitute it. So we can substitute the value of either y square or x square. So for example, in this case, the value of y square from here can be written as x square into 1 plus y divided by 1 plus x. No? See, if you take 1 plus x from right hand side to left hand side, then it becomes this. So instead of y square, write first of all this. Yeah. And now you can see that you can take a lot of things common. And instead of x square also, you can put y square into 1 plus x upon 1 plus y. Or should we even put that or not? Just a minute. Yes, we need to substitute x square as well. So x square would be y square into 1 plus x divided by 1 plus y minus 2y into 1 plus x, right? And by further calculations, I am taking x into 1 plus y from the numerator common, and then it will be left with, if I take x into 1 plus y common, then it will be left with x upon 1 plus x in the first term minus 2 in the second term. So I have taken the LCM of all of this thing, and after substitution it will become like this. Okay, again we can take y into 1 plus x common from the denominator. तो जो मैंने सिर्फ अभी लिखा हुआ है, whatever is written right now, this is your whole numerator part, whole numerator. So I'm writing this so that you can reach to these steps when you solve this yourself. Divided by, and if I take common from here, this will be y into 1 plus x. You will be left with y here, y upon 1 plus y here, minus 2 here. So it will become 1 plus y also, and then it will become y minus 2 minus 2y. Okay, this is not what we want. Okay, we could have solved it further. My bad. From this, let's multiply them. This becomes x square plus x square y is equals to y square plus y square x. My bad, guys. And this can be solved further. You can take y square left hand side, and you can take x square y to the right hand side. This can be written as x square minus y square and y square x minus x square y. Now x minus y into x plus y. Take yx common. This is nothing but y minus x. If you take xy common, this is y minus x. Right? Right? You can see this. Now,
Sir.
X minus y will cancel out y minus x and will only take minus 1. I mean, if you take minus common from y minus x, it is nothing but x minus y. So this is x plus y is equals to minus xy. So rather than solving like this, I mean, we can also go through this calculative approach, but it will take a lot of time. The whole point is to reduce the time. This will also give you the answer, whatever you were doing before, but after a lengthy substitution, this can rather very easily give us the answer. If we substitute, or sorry, if we reduce the function from this form itself. So this is x plus y divided by minus xy. Now you take x from there. So what is this? This is, and take x from there. So x is in multiplication. Here it will come and divide. Or rather take xy from there. Because what is minus xy? This is minus 1 into xy. So I'm taking xy from the right hand side to the left hand side. So this becomes x upon xy plus y upon xy is equals to minus 1. This is nothing but 1 upon y plus 1 upon x is equals to minus 1. Basically, I'm trying to find out y in terms of x. So y in terms of x can be found out rather easily. Sorry, my bad. All the steps were same. Sorry, I'm just writing it in the correct form. Every step is same. Whatever you have written was correct. So this should be x square plus x square y is equals to y square plus y square x. Then x square minus y square is equals to y square x minus x square y. Then x plus y into x minus y is equals to minus times xy, x minus y. Then your x minus y gets cancelled out. Then x is equals to, or rather, this is x plus y plus xy is equals to 0. So I'm taking y common from second and third term. So your value of y is nothing but this. This x goes to the right hand side, this becomes minus x. So y is into 1 plus x is equals to minus x, and then 1 plus x also goes to right hand side. So your dy by dx would be the differentiation of minus x upon 1 plus x, which needs quotient rule. So according to quotient rule, denominator is square, then differentiation of numerator minus 1 into denominator as it is minus numerator as it is, differentiation of denominator, which would be 1. So this is nothing but, this becomes minus 1 minus x plus x divided by 1 plus x whole square. Minus x plus x gets cancelled out. It becomes minus 1 upon 1 plus x square. So dy by dx is equal to minus 1 upon 1 plus x square. As I told you, this was a very important question. Very good question, actually. The most difficult questions to deal with are the questions which needs proving part. Right? Yeah. So if cos y is equals to x into cos a plus y, right? With cos a not equal to plus minus 1, prove that dy by dx is equals to cos square a plus y divided by sine. You need to find out dy by dx. but you don't have y in terms of x. But rather than having y in terms of x, you do have x in terms of y, because x is equals to what? Cos y upon cos a plus y. No. So you have cos, I mean, you don't have y in terms of x, but you have x in terms of y. Shalom, let's try this for 2 minutes, then I will solve this if you are not able to. Anji, anybody able to solve the given question? Yeah, so as I told you that we do have x in terms of y, we don't have y in terms of x directly, but we have x in terms of y. How can we write x in terms of y? As cos y divided by cos of a plus y, right? So till now we have been finding out dy by dx. Why can't we find out dx by dy this time? And then we take reciprocal of that. No. So differentiating with respect to y, both sides. What do we get? We get dx by dy on the left hand side, right? And on the right hand side, we need to apply quotient rule. See, the variable is y. A is a constant only, right? Was a constant only. So variable is y, and you are differentiating y with respect to y. So bas सीधा go. I mean सीधा we have to apply quotient rule. What is quotient rule? Cos square of a plus y. Then cos of a plus y as it is, denominator as it is, differentiation of numerator, which should be minus sine y. Now we don't need to go for y because differentiation of y with respect to y is 1, right? Minus, then cos y as it is, differentiation of cos of a plus y. Cos of a plus y would be minus times sine of a plus y.
Sir, I got the answer.
Yeah, good. How?
Sir, like this only, sir. After that, reciprocate it.
Okay. So I'll ask you one question in between. We just need one answer. So uske baad we will reach to the proving part. Yeah. So differentiation of a plus y. Differentiation of a would be 0 and y would be 1. Right. So this will be the whole formula. So this will become dy by dx. Sorry, dx by dy is equals to, this becomes minus times cos of a plus y into sine y. This becomes plus of sine a plus y cos y. And this is your cos square a plus y. Yeah. How can we write it? Can we use any formula here, Chavez? That is what I would like to ask.
Yes, sir.
Which formula?
Sine A cos B minus cos A sine B.
Would be, what's the answer of it?
Sine of A minus B.
Sine of a minus b, correct. So consider this angle as capital A and this angle as capital B. Then this angle would also be capital A. This angle would also be capital B. Now see, sine A cos B minus cos A sine B. This is a formula. This is a formula, actually. You must have written it in your center page if you ever formed a center page, like I told you. So this was sine of A minus B was what? Sine A cos B minus cos A sine B. Use that formula here. So it will become dx by dy is equals to, this is nothing but sine of A minus B. So you know the angle A. Angle A is A plus y minus angle B is y divided by cos square A plus y. This is nothing but A minus B. Right? So this is sine A divided by cos square A plus y. This is the value of dx by dy. We needed to find out dy by dx, which would be the reciprocal of dx by dy. And similarly, the reciprocal of right hand side also, which is your required answer. Right? So that is how we can, calculate different questions, but you need practice for this. So I would suggest every one of you to solve some questions from here. Assignment. So we have already assigned you a lot of questions from this, but what we would like to start with is, what's the date today? 21st August. 20. Yeah. Let's start with some of the questions in this. 23, 21. In fact, rather than 21, I would like you to solve 22. So 22, 23, then you won't be able to solve actually a lot of questions from this. But I need every one of you to try these questions and let me know which questions you were not able to solve. Uh, yeah, I guess that would be enough. These questions you need to solve by the end of next class, which should be on 23rd. Right? Solve them out and let me know if you're facing any problem with that. And please stay for the